geologists are coming as they're trudging down the hill. When they say that mountains young, they're talking 10 to 20 mil. They're classifying rocks from destruction to rebirth. The geologists are coming, they're converging on the earth.
Hi friends, it's me. This is Mel. Welcome back to Geology Time. We're going to read Chapter 8 today, and it is about mountains. We got a little preview into the chapter yesterday, but we're going to read it now. So let's get started. Okay, Chapter 8, Earth's Mighty Mountains. How do movements and forces of tectonic plates build mountains? The year was 1953. Mountain climbers Edmund Hillary and Tenzing Norgay stood on the hard-packed snow. They gasped for breath in the thin air, their faces burned from the bitter cold wind. Despite this, they were grinning from ear to ear. Hillary and Norgay had just made it to the top of Mount Everest. They were the first people to reach the Earth's highest point, 29,029 feet above sea level. Mountains are some of Earth's most awe-inspiring features. In 1953, geologists were still searching for answers as to how mountains form. By the 1960s, scientific evidence pointed to plate tectonics as a driving force behind mountain building. As you read in Chapter 2, our planet's rocky exterior isn't one solid piece. It is broken up into a collection of gigantic tectonic plates. Earth's tectonic plates move slowly, but their movements have dramatically changed Earth's features over time. Plate movements have shuffled Earth's continents into different positions, they've destroyed old oceans and created new ones, they've also built mountains and mountain ranges in several different ways. Next page. Continents. Some of Earth's highest mountain ranges formed as sections of continental crust collided over millions of years. The collision that formed Mount Everest is a good example. Everest is a part of the Himalayas, a vast towering mountain range between India and China. The Himalayas formed when continents on two tectonic plates met head-on. Can you find India on the map? It's probably this country right here with the arrows that says India. That's my guess. It lies along the southern edge of Asia. India wasn't always where it is today. Hundreds of millions of years ago, India was an island. It sat out in the middle of the Indo-Australian plate. It was separated from Asia, which sits on the Eurasian plates, by an ancient ocean called the Tethys Sea. The Indo-Australian plate began creeping northward about 200 million years ago. Driven by moving magma in the mantle below, it slowly collided with the Eurasian plate. Where the two plates met, subduction took place. The heavier oceanic crust of the Indo-Australian plate slid under the lighter continental crust of the Eurasian plate. So here's how it happened. So there's India moving on up. It collides, and then it melds together. Fascinating. Okay. As the Indo-Australian plate kept moving northward, India was carried along with it. It inched closer and closer to Asia. The Tethys Sea began to disappear. India finally collided with Asia around 40 million years ago. India's rocky continental crust pressed directly against Asia's continental crust. As the two land masses continued to be pushed harder and harder together, the continental crust began to crumble. Enormous pressure created by the moving tectonic plates caused the rocky crust to heave upward. Great masses of rock gradually rose up into a series of enormous folds. The Himalayas were born. More and more rocks were uplifted as the Indo-Australian plate kept moving. The Himalayas rose higher and higher. In fact, they are still rising. They are growing taller at about the same rate that your fingernails grow. Geologists classify the Himalayas as fold mountains. The name refers to the way rocks are pushed up into huge folds by moving tectonic plates. The Alps, Europe's highest mountains, are fold mountains that formed much like the Himalayas. The Appalachians in North America and the Urals in Russia also formed through collisions of continental crust. That's crazy that they're growing at the same rate as your fingernails. That's crazy. Faults and blocks. The longest, highest mountain ranges on land are mostly fold mountains. However, moving tectonic plates build mountains in other ways. Fault block mountains form when gigantic blocks of rock move up and down along faults. At some faults, such as the San Andreas Fault in California, blocks of rock move horizontally past each other as they slip. At other faults, slips cause blocks of rock on one side of the fault to move up. These slips also cause blocks on the other side of the fault to move down. Repeated slips gradually force these rock blocks higher and lower to create fault block mountain ranges. Fault block mountains typically have one steep side and one sloping side. The steep side forms a high sheer cliff. Germany's Harz Mountains are one example of a fault block mountains. Others include the Grand Tetons in Wyoming and the Basin and Range Province of Utah, Nevada, and Arizona. So here they push against each other and then one slips under and it makes a mountain that sort of looks like that. I've been there too. Cool. Under the dome. Most people think of sharp, jagged peaks when they heard the word mountains. Dome mountains are quite different. Dome mountains look like great humps of rock with rounded tops. They usually occur as isolated mountains on otherwise flat plains. Some dome mountains form when magma pushes upward into Earth's crust from the mantle. The magma cools into igneous rock before reaching the surface. This huge lump of igneous rock causes the crust above it to bulge like a blister on a skin. Utah's Navajo Mountain is a good example of a dome mountain that formed this way. Oh, interesting. So it's like magma under the earth. So here's the crust, here's the magma, and then it causes it to like dome up, and then it hardens. You can see the Black Hills of western South Dakota from a long way off. These dome mountains rise up from the surrounding grassy plains as dark, hunched shapes. They are the highest mountains east of the Rocky Mountains. Very ancient granite forms the core of the Black Hills. Millions of years of weathering and erosion have exposed this igneous rock in many places. That's where, here. There's the Crazy Horse. And Mount Rushmore. Interesting. So now we know about the 3 different types of mountains. Okay, so we just read chapter 8. And the cause is tectonic plates subduct underneath one another and move up and down against each other, and magma pushes up into the crust. So that is describing tectonic plates subduct under one another, move up and down, and the magma pushes up into the crust. So that's describing those types of mountains. So the evidence that the tectonic plates are doing that are the 3 types of mountains. So there was the fold, fault block, and dome mountains. So those are the 3 types of mountains that we learned about in chapter 8. Yeah. Oh, this is page 7. Yeah, this is page 7, by the way. Okay, so we're gonna look, we're gonna turn to page 9 and see if we can find a picture that shows the mountains. Okay, cool. So we actually used this picture of the Grand Canyon last time. So we have 2 options now. That's crazy. So it looks like this one's still seafloor spreading. I can just zoom in. And then looky there. Right there we got the different types of mountains. Cool. So an E is where we're going for. We're going with E. Let's go back to page 7. Okay, so right here you're going to glue the picture of the mountains and letter E. Okay, yay. All right, we're going to figure out what the riddle and what the answer is soon. Cool, all right, bye.